So welcome back. Today we discuss requirements for software projects. And we will cover subjects such as typical traps we can fall into as software engineers or as project managers. Solutions that will help us avoid those traps. Some basic terminology related to this field, and we'll discuss some examples of bad requirements, and then we'll try to prettify them and make them better. Let me ask a question first. Did anyone ever write requirements for a project?
We had a lab assignment on a project previously. I think
You and I, or you and someone else?
someone else.
Uh-huh.
We had to write requirements for some project we chose.
Yeah, we had the coursework and we had first of all to do the requirements.
Uh-huh. That's interesting news, because I was planning for something like this to be a next assignment for the course of systems design.
We do it again and we'll go there.
Well, we'll see if what I tell you today is nothing new, then I guess I'll change the plan. Otherwise, we'll go on. So you have some experience in that. What did you obtain as a result of working on that assignment?
We got a huge list of requirements which we obtained in a team.
So you got a list. Anything else? Did you have any images, perhaps? Diagrams, flowcharts, UML paperwork.
No, it was the requirements which we extracted from speaking with the client.
Mm-hmm.
The task was
And who was the client?
we were working in teams,
Mm-hmm.
and one of us was a client and the other one was
Server. Mm-hmm.
I don't know how it's called.
Requirements analyst,
Requirement
project manager.
project manager.
Mm-hmm. And you said you produced a huge list. How huge was it? 2 pages?
Yes.
Mm-hmm.
Well, yeah, for requirements maybe this is not a lot, but
Mhm.
it was a lot for us because we were planned to work on a small project, but when we started to write requirements, we had a lot of them. So
Mm-hmm.
big for us.
Why is it important to write requirements? Why waste all that time and build a 2-page list when you can start programming right away?
To escape some
Misunderstandings?
misunderstanding by people who are using this software and thought isn't working or is working slowly.
Mm-hmm. So you can avoid misunderstandings. What else? What are the other benefits of writing requirements?
Requirements is a list that proves what the client wants, and the client won't change his mind like overnight and say, I didn't say this or I didn't say that. It will be something which will prove that he wanted this and he paid for this and he will obtain this.
So how can I sum it up as 1 or 2 keywords?
I don't know exactly, but something like
Formal agreement.
Formal agreement, yes.
So we're now making a list of pros why we should write requirements. What happens when you don't write requirements and you start programming right away? What's wrong with that?
It's nothing wrong, but maybe
You are not sure how should look the program, the final.
So you don't know
What to build?
when to stop.
Oh, yeah.
Mm-hmm.
maybe you have an overall idea of what you are doing. For example, I don't know, like shop, online shop, okay.
Ah, gotcha.
Maybe this is, you have an overall idea, but when you start to get to the details level, you will start to have questions and you have to take decisions like, intuitively without knowing exactly what you want, and this may lead to more work to be needed in order to satisfy the plan. You don't have a very well-defined direction
Mm-hmm.
for the work process.
So, how can I summarize that in several words?
One second.
Clear objectives, perhaps?
Clear objectives.
By the way, I have to say that one of the good things one of the things that makes requirements good is the fact that they are short and to the point. What you just said was a long phrase, and you could boil it down to 2 words. When something is really, really long, the probability that people will not read it until the end goes higher.
Okay.
That's why you should always try to distill your thoughts into a few keywords. And I do this all the time in our classes, if you noticed. Whenever you tell me something really, really long, I insist that you condense it into something shorter. And when you make a cheat sheet to cheat at the exam, if it's small, then you can easily find your information. But when you bring a whole book as a cheat sheet, it's really not effective. Yeah?
But, most of the time I do this because I'm not sure of my answer. So maybe in this long phrase you will find what's good.
I'll pick the right keywords and make the right answer.
No, I mean like from this, I will give you more information and you'll be like, aha, I understand what you are thinking and this is good or bad, or because I'm not sure of my writing.
Have you heard about the clever Hans effect? Have you heard about the horse who knew how to do math? No? So I will make a small deviation. It's an interesting story. So in the past century, there was a dog somewhere, or a horse, somewhere in Austria. And the horse's name was Hans. And Hans was really intelligent because Hans knew how to sum numbers, how to do subtractions, and all sorts of mathematical operations. And the news began to spread. Everybody was enthusiastic about, wow, Hans, how does he do that? And different people thought that maybe there is a trick somewhere. This person who is the owner of Hans is probably a charlatan, because he was organizing performances and you could pay me just 50 shillings or whatever they were, pfennigs. Anyway, so you would just pay me just a little sum and I would show you how my horse knows how to do math. So some skeptics began to analyze what's happening, trying to figure out where Hans is cheating or where the owner of Hans is cheating. And they paid attention to all the workflow of how it works. They tried it in different ways and no, it was all legal. There was no flaw in this experiment, nobody was telling Hans the right answer. It really worked as advertised.
But how did the horse speak or say or choose the answer?
So the experiment goes as follows. Let's say I'm Hans, and you ask me, how much is 3 plus 2?
How much is 3 plus 2? Whoa.
So he would hit the ground 5 times, and that's the result returned by the function.
To the power 100.
So that's
Go somewhere else.
the interface between Hans and the rest of the world. And then at some point, one of the persons who was investigating this whole affair came up with a slight twist to the experiment. And they reran it, but without the owner looking at Hans. So basically, I would be facing your back. Well, I mean, you would be facing my back. And you ask me, Hans, how much is 3 plus 2? And Hans would then give completely wrong answers. And then it turned out that what really happened is that while Hans was hitting the ground, he was watching the facial expressions of his owner. And that's when he knew when to stop, because the owner was worried a little bit. But when he finally reaches 5, or whatever the right answer is, then the owner has this relaxed face, and Hans was actually parsing his facial expressions. It had nothing to do with mathematics. It was just a simple mammal-to-mammal emotional communication. So just by paying attention to the mimics and the facial expression of the owner, Hans knew when to stop. But when there was no way to see the face of the person, Hans didn't know when to stop, hence the experiment failed. So when you told me why your answers are long,
Sometimes.
I remembered about Hans. So, and sometimes this actually works. When a student looks in the face of the teacher, and the teacher's facial expression sometimes leaks out information about the correct answer. For example, when I ask a question and you give me a wrong answer, I may say something like, and what if you think about it a little bit more? I rarely say, no, it's wrong. In fact, maybe I never say that. But I usually give you a chance to say the right thing when you've said something wrong. So, getting back to the requirements, clear objectives. Oh, and by the way, that's why it's known as the clever Hans effect. It applies to multiple circumstances, including student-teacher communication. Let's think about requirements and cost. How do good requirements impact the cost of developing a software project?
If the requirements are final, the client wouldn't need to pay more for the project to be redone.
Okay. How do requirements influence the time it takes to develop a project?
Okay, developer doesn't need to bother the client day after day to get the requirements, to get what he needs to do, but he knows what to do and he just does this.
So
It's one part.
the process goes much faster because there are no interruptions, there are no discussions about how do you want this feature to work. Are you sure you want it this way, etc. Well, generally that's correct. Though I was thinking about expressing this in other terms. So let's say this is cost and this is time. And this is the lifetime of the project. At first, it's an idea. Then we sketch this idea on paper. Then we try to formalize it and write requirements. Then we began to develop it. Then we install Okay, well, let's say we test it, then we deploy it on some real-world server, and then you actually release the product. It's not an accurate chart, but yeah, it's not accurate. I have to. So, if you have an idea and you end up changing something in it, you just change your mind and that's it. So the cost of changing your mind, let's call it epsilon or even 0. Now the moment you begin to write something, to draw some charts, some diagrams, you've invested some efforts, and it means that you will have to change some of those things. So the cost is a little bit higher. Then you begin to formalize your requirements. Then you begin to implement this in code. Now imagine that you have already written some modules. And at some point, a person in the team says, you know what, we need to make it pink. Or we have to make sure we support HTML 6.3 because that's a very good standard. And in that case, you end up having to change some of the code you've already written. So the cost is higher. So the general point is that the further you are in the future, the greater is the cost of making a change in the program. And it's extremely high. Well, maybe it could have been something like that. It's very, very high when the program is already deployed and in use. And the longer it is being used, the greater the costs are. So imagine that you're about to launch. No, you don't have to imagine it. 9 years ago, NASA launched a probe that is on its way to Pluto. And they set it on the right course. And it has been in transit for 9 years. And just a couple of days ago, it got out of hibernation mode because it is approaching the target. And it sent back a command, a message saying, I'm okay, this is my self-diagnostics, awaiting new instructions. And imagine that it turns out that something is wrong with the software on that probe. How are you going to change it? Are you going to send an engineer to the data center to restart the server? Or to do a power cycle, or to unplug it and plug it back? It's really not practical. So in this case, the cost of changing anything in the device is extremely high.
It's different because we can't.
Actually, you can.
You can send another drone which would, well, why would you send a drone to repair it if you can send a drone to do it?
Well, that's why the people who launched it, they thought that, we carefully plan what we do. But if there is a mistake in what we do, we ought to be able to correct it at a later point in time. So they do have some protocol for patching the software remotely. Of course, you have to be extremely careful when you patch it, because if you make it wrong, if there is a bug in the patch, then you might end up with a brick on its way to Pluto.
That would be really funny to make a mistake in such code.
Actually, there were several cases in history when this did happen, and the devices, well, these autonomous systems were patched remotely. I think one of these cases involves a rover on Mars, which had a firmware issue, and it had to be reprogrammed, and people thought about it a lot, and they sent a patch, and the problem was resolved. But it's one thing when you are at the paper and pen phase, when you drew something here, And you show this to a colleague, and the colleague says, you know what, this arrow shouldn't be here, it should be there. And you say, indeed, let's correct it. And that's your fix. Or, let's say they have already implemented the software, but the thing is still on the planet. Nothing was launched yet. Sure, we can go ahead and patch it. If it's already in transit, then there is no undo button for that one. You cannot unsend it from outer space. So in that case, the cost of a change is really, really high. In fact, during the break, I'll do some quick research, and I will try to find out some details about what exactly happened and what they changed concerning that Mars rover. And a lot of things happened throughout 9 years. If you've been paying attention, at the time they launched the probe, Pluto was still considered a planet according to the definitions of those times. Nowadays it isn't. It's a small planetoid or whatever the new definition is, but not a planet anymore. So imagine how this probe feels when it wakes up and it sees Pluto and everybody now says it's not a planet anymore. What a drama. You could say the same about a system that is used on this planet if it's already deployed. Let's say you are using some form of cryptography for identifying enemy jet fighters when you're flying. And imagine that at some point someone realized that there is a bug in your crypto. But all those planes are already flying and they're already killing people and defending the country. Sometimes you may be able to remotely update them, but sometimes it may not be an option for reasons such as radio silence. You know what this is? What is it?
Radio silence?
Yeah.
People establish a time where they don't send messages.
Any form of communication.
Any form of communication.
And why is it done?
I know an example of war, because to enemy won't find their location.
They plan something big, for example, and they don't want any
Leaks. Exactly. So that's radio silence. Basically, you and your teammates agree from this time to this time not to use any form of communication whatsoever, even if it's encrypted. But the fact that you are exchanging messages already might reveal a few things about your intentions.
Well, the fact that you don't send any messages might reveal something as well.
Yeah. So when no one says a thing, something is about to happen, probably. So imagine that you are supposed to be committed through this decision to have radio silence, and then you realize there is a bug, and if you don't patch it in time, all your planes are going to blow up because of an accumulation error in some integer variable. What are you going to do? So that's why it's a very good idea to anticipate all those issues and take them into account when you devise the requirements. Yes, the process of writing requirements takes time. The process of writing good requirements takes even more time. And you might say, well, we are wasting this time when we could have just paid some programmers and they would have started writing code for us. But the problem is that you have some short-term gains at the expense of potentially really, really painful experiences in the future. So that's why I think a lot of companies neglect the art of writing decent requirements. And that's why you should know that actually it's a really important phase and you should not overlook or just disregard it as a waste of time. So, did I convince you that the more time goes by, the more costly it is to change or to fix a problem? Okay. let's talk about basic traps that people can fall into when they write requirements. I'll be the first one to suggest that requirements can be ambiguous. What does that mean? Can someone give me an example of an ambiguous requirement? Go ahead.
I want this website to be very beautiful.
Very beautiful. Okay. So usually this involves some subjective thing that cannot be quantified unless you are explicitly describing it in fine details. So a beautiful website. What is a beautiful website? If you ask 5 people, you'll get 5 answers, and I'm not sure there will be any form of overlapping between those 5 answers. So naturally, this brings us to a counterpoint for ambiguous requirements, which is make them unambiguous. So in the case of a beautiful website, how would you rewrite that requirement in order to make it specific?
Color, size, positions of elements.
Mm-hmm.
Something like
Our description, our design description, sizes.
Okay, so you basically break it down into subcomponents and you define each subcomponent.
Color, effects, description of these components.
Yeah, that's right. Though, one thing about colors is that men and women don't often agree when it comes to colors. So maybe you could just give the RGB notation of each color. For example, you are wearing green, and so am I, but it's not the same flavor of green.
I thought you will say, but not every person, well, black humor, it's not, don't see, I mean, like, not everybody sees, and also not everybody perceives colors like.
Yeah, actually, perception is very, very subjective. In fact, not only that it is subjective, but as far as I remember, the eye has cells of 2 types, bastonacious conur, cones, and the other ones. Yeah, one type of cells, sensors perceive light intensity, others are color sensitive. And I cannot give you a citation right now, but I might look it up. Women have more cells that are able to distinguish different colors than men. So that's why ladies can usually give you a much more refined description of a color, whereas men just have 3 or several options: green, blue, black, and the rest.
Now I get it. We had lots of discussion about colors. I mean, like, we have lots of discussion about colors and we argue a lot about it. So now I get it why.
Then there is also this philosophical concept, qualia or qualia. Has anyone ever seen this word?
just
You saw it just now. So the word quality is based on this. And if you go to Wikipedia, there is this entire nice article about the concept of qualia and how you cannot really know, you cannot compare people's experiences. For example, if I say, I have a toothache, and you say, I have one which is worse than yours. How can you say that? You cannot measure mine with a painometer and then do the same for yourself and compare the numbers. It's subjective. Some people are more tolerant to pain, others are less tolerant. Some are more sensitive because they've just eaten something that makes them more sensitive. There is this experience which forms the way you perceive your life. So people with one experience do the same thing and they feel it in one way, and someone else with another lifetime background sees it as a completely different thing. So I encourage you to have a look at that page and read about it, so just you know. Yeah. What other things can go wrong with requirements?
They can be, what does it called? Well, one says the color has to be black, and another says the color has to be
Okay,
black.
so they can be self-contradicting.
Yeah, contradictory.
As you said, as a result of your work, you made a list which was long, and we laughed about it being, oh wow, 2-page long. But you know, in reality, requirements can be really, really huge documents. And because they are huge, there is this risk that some people will just skip a few paragraphs. You know, what's wrong about that, right? And you might not notice that some of the parts are in contradiction with other parts of the document, which is of course bad, because you cannot implement that in software. At some point the program has to do X, and at another point it says the program has to do not X. What is the program supposed to do? So this is a bug in the requirements themselves, which in an ideal world should have been fixed by rewriting several paragraphs in the document before anyone writes a single line of code.
They should agree on the requirements, the client and the
Server?
They should firstly agree on the requirements, and after that, begin to work.
So how?
Ideally, at least.
Yeah, but sometimes you can have something so huge that by the time you by the time you're finished reading page 2, you forgot what was written on page -20. It happens all the time. Remember the magic number 7 plus or minus 2, the paper about how much stuff people can keep in their short-term memory? Well, requirements are the same thing. It's a document you have to read, comprehend, and if it's too much, then you just begin forgetting about it. So how do you deal with self-contradictions?
Maybe write some things down, and when you deal with something related to it, you go back and see if there is no contradiction to it, for example.
We can use a Jesus. Okay.
You can use Jesus?
I mean, we can encapsulate different ideas so that we don't need to keep in mind everything before it. We have a component which is described separately, like in object-oriented programming. So this will, the reader will have to focus just on
one thing?
On one thing, yeah, and not keep in mind all the previous parts of the document. But this is not possible, I think, to every project.
Well, I guess it depends on the nature of the project. If it's something you can break down into components and then focus on each component in part, then why not?
And also there is one more thing we can do. We can write the requirements in a specific way. For example, I've read one of your articles about sporadic nodes, and like explanations which sporadic explanations which you, for example, you have a variable and you explain it here and then go there. I mean, you explain more things at a time. And we can write it in a way which will be easier for the user to read it and
to perceive.
Yeah.
Yeah, I remember that story. And you can also rewrite it in a much more concise form. such that it takes less space. You know, besides that thing that you read, I wrote a guide for pupils and students a couple of years ago. It's called Concepte despre conspecte. It's in Romanian with a lot of pictures. And there is even a video lecture in English of me.
The sound is awful.
Yeah, the sound is bad. It's called the right
Yeah,
in English.
I started, but it was like so awful.
That's a shame. Yeah, we didn't have this fancy camera back then and this nice remote mic. Too bad.
We can do it again. Maybe we can.
Maybe we can. We could do this with younger FAF groups to tell them something useful. Anyway, but the guide itself is written in Romanian, and it's not long. It's maybe 15 pages with a lot of pictures. So you can read it really fast, and you can apply a lot of those ideas in... Yeah, what he's saying is that it's now the last semester of your entire student life. But wait a second. Aren't you going to get a master's degree, a PhD? You were supposed to become a professor of science and technology, weren't you? Anyway, even when I take notes at work, when I talk to people, I always use the same techniques. For example, this is my set of notes for this class. I wrote them on the way to the university. And I will be able to expand this into into 2 lectures. But normally this would take maybe 1/3 of the page. But I was on a bus and the road was slippery. So, what other problems do requirements have? Can someone give me an example of an incomplete requirement?
The software has to support internet.
Internet?
Yes.
Well, it's ambiguous.
Well, I wouldn't call it ambiguous. I would call it wrong. You mean Internet Explorer or
No,
Internet?
like as in web.
Uh-huh. Well, this one, I would just say that it's very, very vague. I mean, the internet, do you refer to protocols, to browsers, to... Well, that's a good example.
Okay, but for less vague and more incomplete, the software should support Internet Explorer without specifying
Which one?
beginning version.
Yeah. So, the software should support Internet Explorer, which is already a shame, but so that's a good example of an incomplete requirement.
Let's go further. The software should support Netscape.
Netscape 4.3. I used to be a fan of Netscape Navigator. Did anyone use it?
No, sometimes.
It had this, and at the top right corner of the image there was this letter N, and it would animate as a star spinning around it when it was loading the page, as far as I remember.
Whoa.
I don't know how they did it, but they worked faster than Internet Explorer. They would load page faster, at least on my dial-up connection. So, give me other examples of incomplete requirements. Stefan.
For example, when the client has changed his mind later, for example, he is not decided, and he gives just some vague answers.
Well, give me an example, a specific example of an incomplete requirement. Anna. Thinking.
It should be, well, it should produce a format that can be creator, I don't know.
Okay.
For example, I say that my application should have categories search by categories, but I don't specify which categories.
Categories. Okay, those are good examples. You got him on tape? Okay, we'll use this evidence against him.
That moment when we did all the effort, not getting the camera, but the camera was still pointing at what.
Yeah. There is other stuff we could say. Infeasible requirements. What does that mean?
Invisible? It's almost like invisible, but I assume it's not.
Well, there is a word in Romanian, studiu de fezabilitate. What is it?
Something that's simply not going to work out, or simply it's not worth it, or something like that.
Well, infeasible means
Oh, real?
it cannot be realistically done. For example, there are some universal constants such as the speed of light. And in your software, in your system requirements, you would say, you have to build me a spaceship that is able to deliver this package from Sol to Alpha Centauri in 5 Earth hours.
Well, theoretically it is possible, but we don't have any...
You've already watched Interstellar or something? Or Contact?
Some other movie.
Other ones.
We just don't have the technology to do that, but it's not impossible.
Well, from this point of view, nothing is invisible then, because
No.
Yeah, you could say
we will have
at some point in the future it will become feasible. Or you can just ask Jesus to help you. As we have already seen, this works.
I think you'll remember.
Okay, if we are talking about the technologies and possibilities that we have at this time, okay, it's a good plan.
Or you could say something like, I want an electronic voting system and I want it ready in 2 days. That's again infeasible. You can throw as many dollars as you want at it. You can bring an army of programmers, the best programmers from Sparta, all 300 of them. But it's still not going to be realistic.
Make affordance of every wall in Chisinau, like 0 for silicon papers on them.
Yeah. Another thing is to have inconsistent requirements.
But isn't incomplete and inconsistent pretty similar?
No, you might even say that inconsistent and self-contradictory could be the same, but it's not. So inconsistency is about, well, let's say you use different terminology to describe the same thing. Or, well, could you think of some examples of inconsistent requirements? And then we'll take it from there. What do you think?
What do you mean by inconsistent in this case?
Inconsistent? Well, you could interpret it in multiple ways. One of them is that it contradicts itself at different points, but that's already mentioned there. So, for example, imagine that you are describing some data structures. And in some parts of the system, you use camel case to to give your functions names and give names to those arguments. And in other parts of the code, you call them like this, func name, using underscores. Or in certain data structures, you say, I am using a syntax. Well, let me come up with an example. In some chapters of your requirements, you call that variable username. And in other parts of the document, you just write user, but you have the same thing in mind. Or you can call it UID, user ID. Maybe the author meant that this is the same as that and is the same as that. But maybe this is actually a different thing. How do you know? You have to read the whole thing, or you have to ask the person who wrote the document. So basically, if you're not consistent with your notation, in that case, the interpretation of the document becomes more difficult. For instance, let's say the person who is going to design the database schema read all of these things. And there is a table in the database called users. And in that table, you have a bunch of attributes. One of them will be UID, another one will be user, and another one will be username. So then the person who wrote the requirements looks at that and says, what the hell are you doing? All of these things are just username. What were you thinking? You see? Or one programmer who implements a function that does something with the user. For example, let's say you have a function called create user. And it has one argument at the input, which is the username. But the person who wrote this function read the whole manual, and he saw terms such as username, UID, and user. So that person interpreted as create user has to have three arguments: the username, the user, and the UID. Again, it's a side effect of not being consistent in your use of terminology. Another example. Let's say in certain points you say this button should be red, and you write red. In some other document or in some other page you say this thing should be 25500 in RGB notation. So if you're not careful, you might not realize that you're talking about the same color, assuming that there is just one type of red, which is when all of it is red. So now, instead of having just one entity in my memory, I have two. And in this case with username, user, and user ID, instead of having just one variable in my mind, I have three. And remember this paper, the magic number 7 plus or minus 2. The more things you throw at me, the more likely I am to begin confusing them, forgetting them, or misapplying them. So that's bad. Well, I'm not even sure about how to phrase this better, but let's say tacit requirements. It's something that no one mentions, but everybody expects to be there because that's the way things are. For example, a system might say a number of things about performance, data structures, formats, and interfaces with other systems, but it doesn't say anything about preserving people's privacy. So does it mean that we make it all public? Or does it mean that we should exert some pressure on the people who want this system to make them tell us what kind of expectations they have about user privacy, for example, or system performance? So basically, we're talking about things that were omitted from the requirements, but everybody thought that you would just naturally realize that it was supposed to be there. Another term is gold plating. Does it ring any bells to anyone? I guess that's a no. Basically, these are some features that were added to the requirements without consulting the people who will then be using this system. It's a feature which the programmers thought is so awesome that everybody would just love. So let's include it. But if such features aren't necessary, they shouldn't be in the requirements document. Why? Andrian. Maybe we should add bells and whistles even when not asked about it.
Make the requirement too big for things that are supposed to be done without mentioning them. Or maybe there were another requirements which describe a component.
Mm-hmm. Could someone give me examples of gold plating? Let's say we are making a system for doctors. You have an X-ray machine that takes X-ray images of people's internals, and then you have to view them in some user interface. And you are relying on some widget engine that comes out of the box with the option of skinnable user interfaces. And you say, well, if I get this feature for free, why not just add some menu in the program's options / GUI. I will add a drop-down list called skin, where you can choose which skin you want the user interface to be in. So in this case, the rationale for adding it is because, well, the library that I'm using gives this for free. Why not implement it? People will love it. You know, maybe doctors will want an interface with unicorns and rainbows and the cat that flies and makes that continuous song. Why not have one of those? So this is an example of some bells and whistles that were added without actual demand. And that's not good. One other reason why it's not good is because this makes the program more complex. Imagine things from the point of view of an attacker. This is your program, and this is how much there is to potentially contain some bugs. If you add more whistles and bells, to the program, then there's more code, potentially more space for bugs, and potentially more attack vectors. So that's one other reason why adding such features is a bad idea. This also includes Easter eggs. Does anyone know what an Easter egg is in software? Then why didn't you say, hey, what's an Easter egg? Ah, thanks for asking. So before I tell you what's an Easter egg in software, do you know what's an Easter egg in the rest of the universe?
Well, it's an egg,
Uh-huh.
painted in some colors or with some images.
So in some cultures, the tradition is that someone hides eggs around the house and the children look for the eggs. So an Easter egg hunt. And whenever you find an egg, somewhere next to it there's some gift. Or if you find 5 eggs and bring 5 more, get a free one for free with some special offer discounts. So Easter eggs in software are some features that are hidden, but if you do something by following a specific sequence of actions, then something interesting happens. For example, did you know that there is a Tetris game hidden in Microsoft Excel, at least in one of the older versions?
I heard about it.
Yeah. Did you know what happens in muTorrent or uTorrent when you go to the About window and you double-click the green logo of the program? Does anyone know? Something terrible happens.
Oh, you mean this one?
No, double-click this one.
Yeah.
Is your sound muted?
Oh.
See?
Yeah, I know this song. It's from
THX.
From THX, yeah.
Does it work on a Mac too? You see, Macs probably... So that's an Easter egg. You can thank me for revealing you the whole truth about muTorrent.
Your Android has also something like this when you go to About and
And you press 7 times, you get some developer menu.
Developer, or when you press the version of the software, you get some kind of game, and you get some kind of a game or some animation or something like that.
Okay. Is it time for a break?
Yep, in 2 minutes.
Mm-hmm. In 2 minutes. Well, let's use these 2 minutes for something interesting. So gold plating. You can also have unnecessary requirements. But this time, I'm not referring, well, gold plating is another example of something that wasn't asked for. But it's related to the system itself. For example, let's go back to our system of storing X-ray images of patients. You might say that I want to add a feature that does a Google Images search for that image and gives you a list of results. So you could perhaps see if there are any websites that discuss medical histories or interesting cases in which someone is analyzing a case that's very, very similar to the one you're analyzing right now. It sounds like a very useful thing. It's not gold plating such as adding an Easter egg. It's something that a doctor might actually use. But unless some doctor specifically asked for this feature, you should not add it, because it turns out that maybe they won't need it. And you will just be wasting time, money, cognitive resources, concentration on implementing that instead of using the same time to implement something else which they actually need.
You mean supporting Internet Explorer 1, for example?
It could be, unless somewhere in their requirements they say we have to have Internet Explorer 1, and they give you a good rationale
Well,
for that.
You doubt they could find something for that because nobody uses it.
Mm-hmm.
I mean, maybe they don't know nobody uses it, but they think that they need it, but they don't know about that.
Okay, I see your point, which is why it is very important to have the requirements be produced not by one single person, but by a team of people, which includes first of all end users, the ones who actually will be using the thing you produce. Developers who can look at the requirement and say, you know what, it's really impossible to implement that. Or if some doctor says, we want to support Internet Explorer, and a requirements analyst says, that's incomplete, be more specific. Which versions of Internet Explorer do you want? And the doctor will say, all of them, making it very specific. But then the programmer should step in and say, you know what, it's really unreasonable to support anything below IE5 because no one actually uses it anymore, or something like that. So basically there has to be some voice of reason that can make things clear if people ask something that's more than necessary or something that's infeasible. You could also have some industry regulators. For instance, if we build a program that manages the schedule of a person, and the program feature says you must be able to have a working day that's 25 hours long, for example. And then the programmer steps in and says, hey, wait a minute, a day only has 24 hours. So it cannot be 25 hours long. And then the industry regulator steps in, a person from Protecția Muncii, who says, wait a minute, according to our law, a working day cannot exceed 8 hours. And within those 8 hours, there ought to be a 1 hour break for lunch. So that's why you have to have these people involved when it's relevant. It could be a system that controls a jet plane that transports hundreds of people across the ocean. And the industry requirements might add some constraints, such as the top speed of the plane or the maximum level of noise that the plane could make while it's in transit. For example, let's say you want to get there really, really, really fast. And the engineers said, you know, we can build such an engine, but it will make so much noise that a person will lose their hearing if they fly for more than 1 hour. So in that case, some person from Protecția Consumatorilor should step in and say, you must not make noise above that many decibels, for example, etc. Okay, let's take that break. I'll do some research about the patch for the rover. And we'll get back to this shortly.